good. Let me take up a question from projectile. Okay, let me take up a question from projectile where a stone is thrown horizontally. Okay, the stone is like this. Maybe you are standing over somewhere, you are standing over here. Okay, let me say if you are standing over somewhere and if you are just throwing a stone from this point, and let us say this is the stone. If this is the stone which is thrown, right, if this is the stone which is thrown, then definitely it will follow certain trajectory. Okay, and what is the path of the trajectory? It's given that the stone is thrown horizontally with a velocity of 10 meter per second. So the velocity of this stone, we can say, let it be into this direction, right? This will be like this. And the velocity of the stone is given to you as 10 meter per second. So this will be the horizontal component. So we can say ux equal to 10 meter per second, isn't it? Now, this will follow a certain trajectory. Okay, what is that trajectory? Trajectory is like this. Due to the gravitational, due to the gravitational pull, this is gradually coming down. Okay, then it will come in this way. The stone is thrown like this, but it will just follow a trajectory, and due to the gravitational pull, it will be approaching towards the ground, right? Now, my dear friends, let me take a certain point over here, maybe. Okay, what are the component of the velocity here? It will be like this and like this, right? And which component is there horizontally? You know it, the horizontal component, and that is nothing but ux, right? And what is the vertical component? Let me name it as uy, right? uy. Now, my dear friends, here you can see the component of u over here is this one. This is basically u, the main velocity. Now, the question is that find the radius of the curvature of this curvature for this trajectory at the end of 3 seconds. So the data is given to you. Let me write it over here. After 3 seconds, right? Radius of curvature for trajectory. Hi, Stormy Sorio. Hello. This is from projectile, this question, where it's given that a stone is thrown horizontally with a velocity of 10 meter per second, and we need to find the radius of curvature for this trajectory. This trajectory is forming a path, right? This is the path which is called the trajectory, and we need to find the radius of curvature of this trajectory, right? After 3 seconds, it's given that after 3 seconds, you know, just note the time, right? Now we need to it's also given that disregard the resistance of the air. So my dear friend, if you're throwing the stone horizontally, definitely the horizontal component is given to you, ux as 10 meter per second, right? Now, what is the vertical component, uy? The acceleration due to gravity is acting over here, right? So we can say that uy, the vertical component, is given by g into t, right? velocity equal acceleration is velocity by time, right? And dg is the acceleration which is acting on the vertical component only. So uy equal to g into t, right? And you are knowing the value of g, 9.8. Put it up. 9.8 into t, t equal to 3 seconds. It's given that t is equal to 3 seconds, you can see. So multiply it with 3, you get the value of uy, the vertical component as 3 at 24 carry to 29.4. So my dear friends, you get the vertical component of your velocity, right? Now with this, you know, the acceleration is also, let us say, if this angle is theta, right? With the main component, with the main horizontal, the horizontal component is forming an angle of theta with the velocity direction of the trajectory where the stone is going. A stone is going like this, okay? This is following this trajectory. Now my dear friends, here you can see the acceleration normal to the tangential velocity. What is the tangential velocity? If this is the path, this is the tangential velocity, right? This is the tangential component. Suppose you are making a circle and making a tangent like this, right? So this is your tangent, right? So the tangential component is this one. So I am writing it tangential. Just consider this dotted line as a circle. Just consider for the time being. If this is the circle, then where is the tangent? Like this, as we did it over here into this circle chapter also. So we are having that concept, I am understanding, right? So my dear friends, if this is coming like this is the tangential component of the velocity, right? So normal to this. So let me take one, the normal acceleration, right? The normal acceleration to the tangential velocity will be acting into this direction, isn't it? Just this will make an angle of 90 degree with the tangential velocity, and this is the normal acceleration. Let me write it as an, this one, right? This is the normal acceleration. Why I am finding it, I will explain, don't worry. Acceleration, right? Now this normal acceleration, this is normal to the tangential velocity, right? Now this can be calculated very easily. How? The component of g is acting over here into this direction, g, right? If this is phi, and if you are reducing this and this is also 90, this angle is also coming as theta, isn't it? If this is g, then component of the normal acceleration is nothing but it's equal to g cos theta. You know, component of g acting along this direction is g cos theta. This one, hope you got it. If this is g, right, and you are breaking the component of this g is acting downward, right? G is acting into this direction. If you break this component, one component will be acting over here and one component will be here, and this is the tangential component, right? So tangential component is nothing but g into cos phi, cos theta, right? So you know what is the value of cos theta? Cos theta can be written from here as ux divided by u, right? Ux divided by u. So we can put the value of g as 9.8, and instead of cos theta, what is cos theta? Is base by hypotenuse. What is the hypotenuse over here? If you just form a right angle triangle, right? You can see here, if you form a right angle triangle, this is your hypotenuse, this is your hypotenuse, right? Now if u is acting into this direction, right, if u is acting into this direction, here we have ux, then what is the value of, what is the value of hypotenuse over here, u, so ux by u, right? And you know the value of ux, put it as 10, so this will become 9.8 multiplied by, instead of ux, just write it 10. This is given to you, my dear friend, right? Divided by u. U is basically, this is the resultant vector, you can see. Here ux, uy is there. So you can also consider the component uy over here, right? So the value of hypotenuse is your resultant vector, which is root over of ux square plus uy square, isn't it? If you just remember the Pythagoras, you just recollect the things, right? This will be root over of ux square plus uy square. So my dear friends, from here we get the tangential acceleration, and we know, we just simply put up the value. This will be equal to, this will be equal to, let me write it, 9.8 multiplied with 10 divided by root over of ux square. Ux square is nothing but 10 square. Uy square is nothing but 29.4 square. 29.4 whole square. So my dear friends, you can see, you are having the value of an, the normal acceleration, normal to the tangential, right? Now let me let me we are on the last step of our solution, my dear friends. We get the value, you just calculate it. I am not going into the calculation. Meter per second square, right? Now from this we know the tangential acceleration is given as u square by r. This is the radius of the trajectory, this trajectory, this circle is forming, then definitely some radius is there, this circle is forming, and this is forming with a radius r, right? So this r can be written as u square by an, u square by an, right? This can be written like this. And we know that what is the value of u square. U is nothing but, u square is nothing but, you just write the value of a u, then square it, u square plus uy square, that means ux square plus uy square, horizontal component square plus vertical component whole square under the root. I am saying this horizontal, this hypotenuse, this is the resultant u, right? So this will be like this, and whole square, that means it will be eliminating the root, right, like this, and whole divided by the normal component of this acceleration. I am assuming certain values for this, just allow me, and let me put it certain value, maybe some gamma is there, okay? So just put up the value of an over here into the denominator as gamma, okay? There, this is certain number, because you are going to solve it and you are having certain number. I'm just put the number over here. You are knowing the value of ux, right? So the radius of curvature of the trajectory, radius of curvature of the trajectory, which is equal to r, is given as root over, this root will be eliminated with this square, ux square plus uy square, that means 10 square plus uy is 29.4 as we did over here. This is root over of ux square, that means 10 square, this is 10, and uy, this component we calculated 29.4 plus 29.4 whole square. This is the same thing which we are putting over here in place of u here, numerator. So 10 square plus ui square, ui is 29.4, so 29.4 whole square. Just solve it, you get the numerator divided by the normal acceleration, this value, put it over here, right? Put it over here, and you get the radius of the trajectory, my dear friends. It is coming around 300 meter around. You can just solve it and get your answer. Thank you so much for watching, my dear friends. Take care. Bye bye. Happy learning. See you into the next class. Bye, my dear friends.